Okay, so now in the last section, we gave you some notes about it, we gave you some theory about it, and then we applied it to one concrete example that I thought helped put some meat on the bones so that you could begin to understand what they were talking about. Now we're going to give you several examples in a row, and my hope is that by the end of these examples, it'll make a lot of sense to you. A normal distribution has a standard deviation of 1. We want to verify a claim that the mean is greater than 12. A sample of 36 is taken with a sample mean of 12.5. So here's your data summarized. The null hypothesis is that the mean is less than or equal to 12, because the claim is that it's actually greater than 12. The alternative hypothesis is that it is greater than 12. And keep in mind the equals always goes with the null for nullified. The p-value is 0.0013. They're just telling you that. Later on, we'll get into how to calculate them. Draw a graph that shows the p-value. So all we're trying to do in this question is show how the p-value relates to how many scores there are overall. Now, I don't think that you're in a position where you're going to show exactly what the p-value is with a graph until you've seen one. So let me show you. Now, here is what you have, the information. The null hypothesis is in the middle, and the null hypothesis all revolves around the mean of 12. And the p-value is this little tiny shaded part to the right. It's the probability that we're dealing with here. So it's 0.0013. That is microscopic, super small. So there's the graph that draws and shows the p-value, okay? Clearly, that is a super small p-value. When using the p-value to evaluate a hypothesis test, it's sometimes useful to use the following memory device. And we'll mention this multiple times over the next couple of lessons. If the p-value is low, the null must go. If the p-value is high, the null must fly. Once again, if the p-value is low, then the null must go. If the p-value is high, the null must fly. I was cut from a church choir, so I guess when I tried to hit those notes, you kind of figured that out. This memory aid relates a p-value less than the established alpha. The p-value is low. When it's less than the established alpha, rejecting the null, that rejects the null hypothesis. Likewise, when a p-value is higher than the established alpha, the p is high, it's not rejecting the null hypothesis. Okay, so fill in the blank. Reject the null hypothesis when the p-value is low. The results of the sample data, I don't understand it. The results of the sample data. If you reject the null, I don't know what they're asking for here with the results of the sample data. Anyway, I really don't know what they're asking for with that. Let's get to the next one. Do not reject the null when the hypothesis is high. Or do not reject the null hypothesis when the p-value is high, because by saying the null must fly, we're saying keep it. It's a good thing. Okay. Now, reject the null hypothesis when the p-value is less than the established alpha value. The results of the sample data support the alternative hypothesis. Okay, now I see what they were getting at here. The results of the sample data support the alternative. If you reject the null, you clearly support the alternative. Do not reject the null hypothesis when the p-value is greater than the established alpha value. The results of the sample data, if it's greater than, it's high, if you will. If it's less than, it's low. The results of the sample data do not support the alternative hypothesis. It's a Boy Genetics Labs. Here we are, back to this again. People like King Henry VIII, they probably were really into this lab, claim their procedure improves the chances of the boy being born. The results for a test of a single population proportion, that's that other formula, the second one we went over, are as follows. The probability should be 0.5. That's the null hypothesis, and the alternative is that it's actually greater than 0.5. Alpha is equal to 0.01. The p-value comes out to 0.025. They're just telling you this. They're not doing the calculations. We will do calculations in a little bit. Interpret the results and state a conclusion in simple, non-technical terms. Go ahead. using stop and start, of course. The p-value is greater than the alpha value, so do not reject the null, okay? And the probability of the baby being born is 1/2 or 0.5, being born a boy, okay? So when the p is low, the null must go. When the p is high, then the null must fly. So therefore, you don't want to reject it because the p value is higher than the alpha value. Okay, a researcher is interested in estimating the mean blood alcohol content of people arrested for driving under the influence. The sample consists of 250 individuals with a mean blood alcohol content of 0.145. Based on past data, the research assumes a population standard deviation of 0.065. What is the 95% confidence interval for the scenario above? Now, it's actually a little bit of, you can do this based on a little bit of a review type of work. Okay, for the 95% confidence level, that's 1 minus 0.95 is 0.05, and then we split it in half for 0.025. So that whitetail area on both ends of the graph is 0.025. Second VAR's inverse norm of that area of 0.025 is 1.96. The error bound measurement, 1.96 times 0.065 over the square root of 50 is 0.008. And that means that we're going to go from the mean minus 0.008, the mean plus 0.008. That's 0.137 to 0.135. So the 95% confidence level, this says 99%. That's because it was an old example. It should say 95%, is 0.137 to 0.153. First choice. Out with the new, in with the old. A review question. The average number of milligrams of sodium in a certain brand of low salt microwave dinners is 660 grams. Okay. Standard deviation is 35 milligrams. Assume the variable is normally distributed. If a single dinner is selected, find the probability that the sodium content will be more than 670 milligrams. Don't forget, what we're working on here is, this is out with the new, in with the old. So we're doing some review work here. Stop and start, of course. Single dinner is selected. That's very important. More than 670 milligrams. So I go to second VAR's normal CDF. And I want to be 670 or higher. So that goes the lowest 670, the highest 10 to the 99th. 660 is the actual mean. Standard deviation is 35, and I get 0.3875. Now, if a sample of 10 dinners is selected, find the probability that the mean of the sample will be 670 milligrams. Go ahead. So 10 dinners is important, okay? And that the mean, the fact that there's 10 dinners in the mean is super, super important. I was actually a little bit confused by this one. I want to use t-scores because there are only 10 dinners. However, there is no list of inputs, and they make mention of the mean of the sample. So I'm going to go with the central limit theorem. Second VAR's normal CDF, 670 is the low, 1099, 10 to the 99th, I should say, is the maximum. That's what we always put in there. 660 is the mean, and then 35 divided by the square root of 10, and I get 0.1831. Okay, so again, I thought it was a little confusing because they said only 10 dinners. Usually you would go with a t-test with such a small sample size, but the fact that they're talking about means here, I think they want to go central limit theorem. Last question. Go ahead. So, some important things. Mean of a sample, 55 families. So second var's second var's normal CDF, 17 is the low, 18 is the high, 17.2 is the mean. Standard deviation is 2.5, but I have to divide by the square root of 55 because this gets into the whole central limit theorem idea and the SE and everything else. When I pump that in, I get 0.7147. Big thing you got to do there is recognize that you must divide by the square root of 55, and that's the key when they start talking about the 55 families, that you recognize that situation. Okay? All right, so we talked a whole lot about, in lesson 22, about type 1 errors, type 2 errors, null hypothesis, alpha, beta, when to reject, when not to reject. When the null when it's low, the null must go. When it's high, then the null must fly, and all those other sort of things. The next lesson, they kind of go as a pair, really gets into some additional information on that. This lesson was all about setting it up. The next lesson is applying it a whole bunch.